Okay, so here we have a slope field question. You're given the slope field on the left, and you're asked which differential equation on the right that it may represent. So remember, these differential equations just represent slopes, and these little ticks also represent slopes. So for example, at this point, I don't know, around 2 comma 2, it's a negative slope. At this point, say like negative 3 comma negative 2, it's a steep negative slope, and so on. So you have to look for little clues in a question like this. First of all the slopes are either x over y or x times y. So we can use our rules of multiplying positive and negative numbers to figure out uh, if the slopes are positive or negative in certain quadrants. And if you look at the slope field in quadrant 1, all of these slopes are negative. In quadrant 2, they're all positive. In quadrant 3, they're all negative. In quadrant 4, they're all positive. So this may be a big clue. Another big thing I'm seeing here is all the little slopes on the x-axis are 0. So that means, I'm looking at these, no matter what value of x, if y is 0, no matter what x is, dy dx is 0. That's because, of a horizontal tangent line. So the first thing I'm going to do is look at these slopes. If y is 0 for the first two, the derivative should be undefined because you can't divide by 0. So I can immediately get rid of these just for the fact that this dy dx has to be 0 for any value of x when y is 0. So that works for these. So C and D are fine. Now look, now you can go by the quadrants. In quadrant 1, all the slopes are negative. So it means for a positive x and for a positive y, the slopes should be negative. So if you look at this, for a positive x and a positive y, x times y would be positive, so that would indicate positive slopes. So really it can't be C. D, for a positive x and positive y, that negative would create negative slopes, so it must be D. So pretty much if I analyze that right, I'm done. I've eliminated the 3 that it can't be, just to make sure. Let's go to quadrant 2. The slopes are all positive. So dy dx is positive, but you have to see that x is negative in here and y is positive. So this slope field, x times y would be negative, and that negative out front would make it positive. So all these slopes should be positive, so that checks out. And you can do the same thing with the last two quadrants. So all of this slope field makes sense based off this. A lot of times, just like I did, a process of elimination is really key. So there you go.